Okay, so this is problem 7.4.15, which is number 6 on the Chapter 7 homework. Um, so, well, let me just read it. Researchers found that a person in a particular country spent an average of 5.3 hours a day watching TV. Assume the population standard deviation is 1.6 hours per day. A sample of 37 people averaged 5.6 hours of television viewing per day. Does this result support the findings of the study? So normally with something like this, we can use the function standardize to find a z-score when we have a mean and a standard deviation. The problem with this is that we don't have an actual population mean. Or I guess what I should say is we don't have the sample standard deviation. So we can use the population mean to approximate the sample mean, but we can't use the population standard deviation to approximate the sample standard deviation. So I'll just start. I always just try to start with what I know. So let's see. I know that the population mean is 5.3. And I know that X, or the number that we're testing for, is 5.6. I know that N, or the sample size, is 37. And I know that the population standard deviation is 1.6. Now I can find my sample, or approximate my sample standard deviation by taking the population standard deviation and dividing that by the square root of the sample size n. So that'll give me a good approximation of my sample standard deviation. So now that I have that, I can actually use the function. So to find my z-score, I can actually use the function standardize. And for my x, I will use the 5.6. For my mean, I will use the population mean as an approximation of the sample mean. And then I will use my sample standard deviation. And that'll give me a z-score for that value of x, which is 5.6. So 1.14, how many decimal? 2 decimals. Now it's going to ask me what's the probability that x bar, meaning the sample mean, is greater than 5.6. So this is the z-score for 5.6. So now, as you know, we can always find less than, and then our greater than for probability is just 1 minus the less than. So if we use norm.s.dis, so that's the standardized, which is what we use whenever we're working in z-scores. We use our z-score of 1.14, and then true for our cumulative, and that will give us the probability that x bar will be less than 5.6. So the probability that it is greater than is just 1 minus that probability of less than. So let's see, 4 decimal places, 0.1270. And then finally, it wants us to know if this result supports the findings of our study. So since our probability is greater than 0.05, we'll say that it does support or supports the findings of the study. And there we go. So hopefully that was helpful to you. And as always, if you have additional questions, don't be afraid to reach out.